In this lecture, we will discuss about 15.3 and we have given missing limit topic. You have given some limits and some are missing, right? So to this, you can sketch the graph and find the limit. This is the one method. But the second method is point of intersection. Point of intersection is whenever there is a graph, two graph, and the point of intersection is the point where these graphs are meet. And these are the limits point. So this is 15.3 topic. So I just take example, question number 3. This is the example. You have to find area element. Area element is dA, right? You don't know how to put the limits. And dA has choice. It can be dx dy or dy dx, right? So we have to see which limit suits this, because in the previous lecture, I have told you that if the function limit comes on the interior integral and the constant come in the exterior integral. So we have to see that either x has the limits of function, either y has the limits of function, right? So we have two limits. X is equals to minus y squared and y is equals to x plus 2. So for point of intersection method, we need both in terms of x or y, right? So I will convert this limit in terms of x. It will convert to x is equals to y minus 2. And this is also in terms of x, right? I get two limits of x. Now I will apply the point of intersection method. I will apply it here. So I have two functions, limit, and I decide to take dx dy because the limits of functions are given in terms of x. Now, we find the missing limits of y. So this is the way x1 compare with x2. This is called point. When two graph meets, their values become same. This is called point of intersection. So we get y squared is equals to y minus 2. And when we solve this equation, it becomes a quadratic equation. And I just do factorization. So y is equals to 1 and y is equals to minus 2. These are the roots of this equation. So these are the missing limits. Y is equals to 1 and y is equals to minus 2. So this is the missing limit step 1. Now the step 2 is to write the integral. So we write the limits. We get x1 is equals to minus y squared, x2 is equals to y minus 2, and our y is between 1 minus 2 and 1. Right? This is the limit of y. Now I have to write the integral. I'm sure that y come here and dx come here. Now I want to see which function is bigger and which function is smaller, right? So I take a value between minus 2 and 1. So value of y between minus 2 and 1 is y is 0. I use 0 in this equation. When I use 0 in this equation, x1 becomes 0. When I use 0 in this equation, x2 becomes minus 2. So x2 is minus 2 is smaller than 0. So x2 is the lower limit because it has smaller value, and x1 is the upper limit. Upper limit are always greater than the lower limit. So this is the formula. It is like dx dy. So in the whole exercise in 15.3, you will do when you have more than less than 4 limits, just take the same limits and compare them, right? Like a point of intersection, I have two limits of x2. I compare them and find the missing limit. Similarly, if you have three limits. I can show you a question like this. If you have three limits, how can you find the missing four one? So if you have three limits, y1 is 2x, y2 is 4, x1 is 0, x2 is missing. So you take point of intersection of two y's because you have given y1 is equals to y2. This say 2x is equals to 4 and x is equals to 4 by 2. So x is 2. So the missing limit is 2, right? And you can write the integral because you know y is given in function. So we will use dy first. Okay. And that x is constant. It's 0 to 4, 0 to 2. Now I have to choose which one is greater. Y2 is greater or y is this greater? So as the limit of x is between 0 to 1, 0 to 2, I will take 1. A number x is equals to 1. I put this number in y. It becomes 2. And there is nothing to put here. So this is a small function and this is a large function. So the large function come upside and the small function come here. It is like, sorry, it is 2x. And this is dx by dx. But this is how you can solve 15.3. If you want any more question to, you can just give me the comments.